So while these forces are acting on an object, it can either be balanced or unbalanced. So balanced forces are when the forces acting on an object are equal in magnitude and opposite in direction. The net force is zero and there is no movement. So tug of war can be a good example to demonstrate both balanced and unbalanced forces. So each of these people on either side, they are tugging on the rope with the exact same magnitude and opposite direction with the exact same strength. So this rope that they're pulling on would not move because the forces from each side are balanced. Unbalanced force is quite the opposite from balanced forces. It is when the forces acting on an object are unequal in magnitude, acting in different directions, or both. This will cause a change in an object's motion. So now the person on the right is pulling with more strength and more force. So the rope is entitled to move towards the right. Now we will go over distance, speed, and average speed, which is quite an important concept for calculating the motion of an object. So distance is the total length of a path covered or traveled by an object. Speed. Speed is the measure of how quickly or slowly an object moves, and the average speed is the measure of how fast an object moves on average over a period of time. So an easy way to memorize calculation of any of these sectors is to use the distance, speed, and time triangle, where distance comes first, speed comes second, and time goes third. And basically the concept is a triangle, so if it's S, it's distance over time. So average speed, it would be distance over time. And time would be distance over speed. And distance would be speed times time. So let's take a look at these two questions for an example. If Sam walks a distance of 10 meters in 2 seconds, what is his average speed? So we want to find the average speed. Let's use the DST triangle. Since we have to find the average speed, we have to do distance over time. So walking a distance of 10 meters would be the distance, and 2 seconds would be the time. So we simply have to divide his distance, which is 10 meters, with time, which is 2 seconds, to find his average speed. This would be 5 meters per second. So adding on, let's move on to the second question. If Sam walks for 10 seconds, how far does he go? Now this talks about the time and the speed. So we have to find the distance because it says how far does he go. So to find the distance, it would be speed times time. So to find his distance, we would have to multiply 5 by 10 seconds, which is 50. So in total, his distance, if he walks for 10 seconds, would be 50 meters. Now that you understand how to calculate speed, time, or distance, let's move on to graphing distance and speed against time. So these are four graphs that are most commonly shown to represent the speed. And these four graphs are all distance time graphs. The first one is for a stationary body. The second one represents for a uniform motion. The third one represents a non-uniform motion and when the speed increases. And the final one represents a non-uniform motion for when the speed decreases. So let's take it why it looks like this and what it represents. So let's take a look at the first one. The first one is a straight line, and it's for a stationary body. So the line is straight to represent the stationary body. The object is at rest, so the line is also straight. There's no visible increase or decrease in time as time goes on. So the distance of the object stays here while time moves on, showing that it does not decrease or increase as time flows. So there's no movement. Let's take a look at the second one. This line is linear to represent the uniform, or also known as constant, speed. It displays the object moving at the same speed throughout the time period. So whatever mark, this indicates that at wherever point of this line you stop on, if you calculate the speed, it will always be the exact same speed because it's a constant speed.